very well that this is also very important for physics, especially differentiation and integration is very, very useful in physics. Those are writing, whether you're writing NEET or NEET, it is secondary thing, but this is very, very helpful. So more concentrate on differentiation and integration. Then vectors concepts also there in our mathematics, that is also useful to you. Addition of vector, multiplication, cross product, dot product, scalar, triple product. Okay, we will discuss that is also very briefly. Okay, don't be absent for this differentiation and integration, right? In the question here, they are asking d square. See here, d square y by dx square. We got dy by dx, that is equation 2. Now what to do? Again we can differentiate. Again differentiate with respect to x. So left side is clearly d by dx of dy by dx. Right side is minus d by dx of 5 sin x plus 3 cos x. Okay, now you can take 5 outside, d by dx of sin x, 3 outside, d by dx of cos x. But I'm writing directly here. 5 into sin x derivative is cos x plus 3 into cos x derivative is minus sin x. Okay,
sir, can I follow up, sir?
Yeah.
Okay, sir.
Okay. Now this is equal to minus of bracket 5 cos x minus 3 sin x. Can anyone tell that what about this value? 5 cos x minus 3 sin x value?
Negative y.
Yeah. This is clearly y. Am I right? Given y. Y is what? Given function is same. 5 cos x minus 3 sin x is a y. Just you have to write negative y. So d square y by dx square. This negative y minus y taken to numerator. Therefore, we are going to get d square y by dx square plus y is equal to 0. So this is a required proof. Okay, finally it will becomes y. D square y by dx square plus y is there. So after differentiating twice, we are going to get a minus y. Surely, otherwise it will be wrong. Already they given. So here some advantage is there that, so already they given indirectly the answer d square y by dx square is equal to minus y. Minus y nothing but the given function minus of this value. Okay, that is the advantage. Whether you get or sometimes you might be get other sign also, you should be right at last. This d square y by dx square plus y is equal to 0, hence proved. Even if you get some other values also, right? Fine, we prove that. Next. Okay, second is y is equal to cos inverse x, find d square y by dx square in terms of y alone. So here the lengthy questions are here. 13th one is, I think so, lengthy, and 14th and 15th around. Remaining and all okay. So before that, I will do one thing. Let us do that easy question first. 16th or 17th. Like we'll go through 17th onwards. First, I'm going to do 17th. I'll explain you all the questions because all are important here. First 17. If you do easy questions, you can easily understand the difficult one also. Y is equal to tan inverse x whole square. Whole square. So this is the given function. What shall we prove here? X square plus 1 whole square into y2. See here, what it will be represent? I told you in differentiation, they can represent in many ways. Y1 nothing but the first derivative, that is dy by dx. Y suffix 2, nothing but this will represent second derivative. So anyhow, here we have to find first derivative as well as we have to find second derivative with the help of given function. Okay, students, this is not at all easy only. So let us take, this is equation 1. Same, differentiate with respect to x. Then y becomes, here y becomes y1. First derivative dy by dx, I have written y1 because the question itself they represent in terms of y1 and y2. Now, okay, y1 is equal to, see here, we can apply the chain rule. First, it is in the form of derivative of x square. X square will be 2x. I want to apply that. Then after the derivative of, tan inverse x. Since we know that the tan inverse x derivative is 1 by 1 plus x square. So y suffix 1 is equal to 2 times of tan inverse x. Okay, otherwise x power n formula, your wish. Again the derivative of tan inverse x. Chain rule. By chain rule. Okay, so y suffix 1 is equal to tan inverse x into the derivative of tan inverse x is 1 by 1 plus x square. So next again we can differentiate, that is y2. How can you find the second derivative, students? For example, they given like, we got finally 2 tan inverse x by 1 plus x square is first derivative. Again, we need to differentiate this y1 with respect to x, then only we are going to get y suffix 2. How can you do the differentiation? That is my question. Left side will get y to right side. What to do? Right side. Yes.
U by V.
It is in the form of u by v. U by v. Yes or no? So instead of doing the u by v rule, in the question itself, we have to prove that x square plus 1. X square plus 1 is there. So you can cross multiply. The differentiation becomes very easy. U by v is very difficult compared to uv. So shall I write, when I cross multiply, we got 1 plus x square y1 is equal to simply 2 tan inverse x. Let us take, this is equation 2. Okay. Now we have to differentiate with respect to x again, because your y suffix 2 is there. Now what to do here? LHS having product of two different functions, UV rule. Okay, apply UV rule. So left side is d by dx of 1 plus x square into y suffix 1 is equal to 2 times of d by dx of tan inverse x. Right side clearly 2 into 1 by 1 plus x square. Here apply UV rule. U, which implies uv dash 1 plus x square into u dash. Nothing but y1 derivative. Y1 derivative is y2. This is already first derivative. Again differentiate, it will become second derivative plus y1 into the derivative of u, that is 1 plus x square is 0 plus 2x. It's clearly equal to 2 times of 1 by 1 plus x square. Now why don't we cross multiply here? This 1 plus x square cross multiply. When I cross multiply 1 plus x square bracket 1 plus x square into y2 here plus 2xy1 is equal to right side is 2. Right side 2 you can take it left side, then multiply with this 1 plus x square. 1 plus x square into 1 plus x square, it is whole square into y2 plus, observe here, 2 times of, already x is there, x into 1 plus x square into y suffix 1 minus 2 is equal to 0. Yeah. Okay, they given here it is equal to 2. Right. I want to keep the 2's right side alone. Hence, proved or not? Yes, students. Clearly, we proved. 1 plus x square whole square y suffix 2 plus 2x into x square plus 1 y1 is equal to 2. So what I have done in this question actually, so I differentiated directly with help of chain rule. I found that the first derivative y1. Finally, we got to 2 tan inverse x by 1 plus x square. Then I cross multiply. After cross multiply, only I differentiate. Even you can do directly also with the help of u by v. Sometimes we may not be get idea to cross multiply. At that time, we can apply u by v rule. In that case also, we get the same answer. But that is somewhat difficult compared to this u. So finally, I simplified. Finally, we got whatever the answer. Now let us go for question number 16. 16 is the given function is here e to the power of y into x plus 1 is equal to 1. So what we have to do here is students, we have to prove that, yes, this is the given condition where we have to prove that, okay, the second derivative is equal to the square of the first derivative. That's it. Second derivative is equal to square of the first derivative. So again, this is equation 1. So what we have to do, differentiate with respect to x. See here, when you differentiate again, product of two different functions, u v. Right side it is a constant, so d by dx of e power y into x plus 1 into d by dx of 1. So u v rule, first u v dash x derivative 1 plus 0 plus v u dash e power y is e power y. Again y is dy by dx. Everyone must be remember e power y. So e power y is a function in terms of y, then e power y is e power y. Y derivative is dy by dx is equal to 0. Okay, 0. So this e power y, you can take it right side. So dy by dx coefficient is what? So this dy by dx term alone you can keep it left side. Then remaining values you can take it right side. That is e power y into 1 plus 0 becomes e power y. That you can take it right side. Minus of e to the power of y. Now, see students. Now what to do here? Can you cancel anything here? Left side and right side. Can I cancel this? What is the remaining value? Shall I write x plus 1 into dy by dx is equal to minus 1? Okay, right. So which implies here, look at here, dy by dx is equal to minus 1 by x plus 1. Okay. See, if you take right side like this, you can do like that also, no problem. Okay. Or you can keep it to UV formula you can apply. So why don't we cross multiply? It's better to do like that. Correct. You can do in both ways. You can differentiate directly here, apply UV rule. Or else if you take right side, 1 by x formula you can apply. Minus 1 by x plus 1. Okay, ma? Right. Now again differentiate with respect to, with respect to x. See here, this is in the form of, since we know that d by dx of 1 by x derivative is what? Anyone? Minus 1 by x square. So must be remember, right? You must be remember 1 by x. So when I again differentiate means here d by dx of left side is dy by dx is equal to minus d by dx of 1 by x plus 1. Observe here, this is in the form of 1 by x. 1 by x plus 1 is same as like 1 by x. Now, so why don't you apply this formula here? Apply the formula here, same. So left side is clearly d square y by dx square. Right side coming here minus 1 by x derivative is minus 1 by x plus 1 the whole square into again x plus 1 derivative is 1 plus 0. Again you have to differentiate x plus 1. 1 plus 0. Finally this is equal to what? This is equal to what? 1 by x plus 1 the whole square. Or we can write minus 1 by, shall I write whole square like this? Minus 1 into minus 1, minus 1 whole square. X plus 1 whole square I have written. Because what is the question? We have to prove that dy by dx the whole square. Left side already d square y by dx square. But what is dy by dx? What is dy by dx here? dy by dx is minus 1 by x plus 1. So I have written minus 1 by x plus 1. This you have to replace as dy by dx. So d square y by dx square value is equal to, this is clearly dy by dx the whole square. dy by dx the whole square. Clear, students? Are any doubts here? Having any doubts you can ask. Okay. This is the required answer. We proved here. We got first derivative, I differentiated again. Finally, we got d square y by dx square is equal to dy by dx the whole square. So few questions you have to do logically. You don't blindly don't go like for example, in objective, especially objective, this kind of questions are, you can cross multiply. Many questions are there like in cross multiply in OBT. So instead of u by v, UV rule is easy. Right, next. Let us do now question number 15. 15th question. What is the 15th question? They given some large values like 500 and 600. 500 into e to the power of 7x. 500 into e to the power of 7x. 600 into e to the power of minus 7x. Then we have to prove that d square y by dx square is equal to 49 into y. See, answer in the answer already given. Okay, so it's not at all difficult. One differentiate with respect to x, so dy by dx is equal to 500 into, I'm doing differentiation directly, e power 7x is 7 e power 7x. Am I right? 600, this is the derivative of e power 7x. 600 into e to the power of minus 7x is minus 7 e to the power of minus 7x. Anything will be common here. Yes, anything is common. 7 is common. Am I right? 7 is common, then it is 500 into the power of 7x plus into minus 600 into e to the power of 7x. This is dy by dx. Next what? Yeah, what I have to do? Twins. Next again differentiate with respect to differentiate with respect to x. When I differentiate again, the left side is clearly d by dx of, okay, d by dx of dy by dx is equal to 7 times of, again 500 into, what is the derivative of e power 7x? 7 e power 7x minus 600 into e power minus 7x is minus 7 e power minus 7x. Okay, ma? Right, this is equal to, again anything is common again. Straight.
So 7.
7 is common. Again you can take 7 outside. 7 into 7 what? See, 7 is common. Again take 7 outside. Already one 7 is there outside. So here it is 500 e to the power of 7x minus into minus plus 600 e to the power of minus 7x. Fine. So finally, what do you observe from equation 1? This value becomes what? What about that value? That value is clearly
Y.
y. This is clearly y. So left side is d square y by dx square. Right side we are going to get 49 into y. This 49. Okay, I think so. This is the only required answer. Yeah, d square y by dx square is equal to 49 into y. Okay. So what we have done here, twins. So simple, right? This is the given function. We differentiated twice. Directly we got the answer. Differentiate twice. But you should write the steps. Like you mentioned the formula, since here you have tried the formula for this one also. Since d by dx of e to the power of ax is equal to a into e power ax. Each and every formula you can try to mention. Okay. Okay. Then let us go for next one, 14th one. 14th one. Till this question, any doubts, students? Question number what? Question number y is equal to a into e power mx plus b into e to the power of nx. Okay, a into e power mx plus b into e to the power of nx. Show that again, if you see here, first order is there, second order is there. First order derivative, second order derivative. So this is equation 1. Differentiate now. Then the dy by dx left side. I'm doing direct differentiation, students. We have to write those steps. It is same as like a 15th question. 15th question, this question is same. Okay. Like m into e to the power of mx plus b into n into e to the power of nx. Okay, this is equal to m a e to the power of mx plus n b e to the power of nx. Fine. This is the first derivative, dy by dx. Now next what? Again differentiate on both sides. Again differentiate means left side is d by dx of dy by dx. Right side is what? M a again e power mx, e power mx derivative, e power mx, e power mx alone. These are only two functions. Those functions only you have to differentiate. So m e power mx plus n into b into n e power mx. Right? M into m. Left side is d square y by dx square. M square a e to the power of mx. N square b e to the power of mx. Okay, here this whatever the first derivative you got it here, this dy by dx, I want to take it as equation. These are the three equations. Like this is also equation 1 here. This is equation 2. Equation 2. Then what is equation 3? Second order derivative is equation 3. This is clearly equation 3. So here first I am going to take LHS. See here we have to show that this value is equal to 0. What is LHS? D square LHS. D square y by dx square minus m plus n into dy by dx plus mny. Okay, this is LHS. So from here you have to write from which equation? From 1, 2 and 3. From first, second, third equation you have to substitute here m square a e to the power of mx plus n square b e to the power of mx minus of m plus n into dy by dx is what? M a e to the power of mx plus n b e to the power of mx. Then what is m n y? M n y. Y nothing but what? A e to the power of mx plus b into a to the power of mx e to the power of mx. So now I substituted here d square y by dx square value. I substituted dy by dx value. I substituted y value in LHS. Now multiply here m square a e to the power of mx, n square b e to the power of mx. Then when I multiplied here m into m square a e to the power of mx minus mn e to the power of mnb. So I'm taking m into this mnb e to the power of nx. Okay, I multiplied with m. Now I want to multiply with n. When I multiply with n, minus n m a e to the power of mx minus n square b e to the power of nx plus, now you can multiply with mn. Mn into a, mn a e to the power of mx plus mn b e to the power of nx. Okay, this is equal to what, students? Is here all terms will be cancelled or not? Cancel. N square get cancelled. Mn b cancel. Minus plus cancel. So final, therefore We got 0. This is RHS. Therefore, LHS equal to RHS. Hence, proved or not? We proved that I am taking LHS. Finally, we got RHS. I think so I am going slowly only. Understood or not, students? Any doubts? I differentiated once, I differentiated twice. With the help of equation 1 is given y and dy by dx, d square by dx square. I'm taking LHS. So finally we got 0. So LHS equal to RHS. Hence proved. If you're having doubts, you can ask. Is it clear till now? Then next. This question number 13, I think so, somewhat lengthy. We're having 2 more problems. Let us do 12th. At last, we can do 13th. 12th one is y is equal to cos inverse x. Little fast. I want to do this. So whenever y is equal to cos inverse x, find d square y by dx square in terms of y alone. D square y by dx square in terms of y. We can do in 2 ways. Student, method 1, method 2. See, in terms of y means just this cos inverse means cos you can take left side. Cos y is equal to x. Cos y is equal to x. Now, this is equation 1. Now we can differentiate. When I differentiate, cos y becomes sin y dy by dx is equal to what? 1. I differentiated now with respect to x, d by dx, d by dx. I differentiated equation 1, otherwise you can take this. They are asking in terms of y, so this is equation 1. 1 differentiated with respect to x, we got like this. This is equation 2. Again, we can differentiate.
Excuse me, sir.
Yeah.
Sir, is it sin y or minus sin y, sir?
Sorry. Minus sin. Cos y is minus sin y, y is dy by dx. Wonderful. So again, we can differentiate. It's better this minus you can take right side. It will become plus. Okay, take minus right side becomes plus. Now this is equation 2. Again, we can differentiate. Here we can apply UV rule. UV rule. What is U? What is V here? This I'm consider as U. This consider V. UV rule. U V dash sin y dy by dx derivative is d square y by dx square. Okay, d of uv formula uv dash plus du dash. Okay, plus dy by dx. Now sin y derivative is cos y into dy by dx. Is equal to right side is minus 1, derivative is 0. So finally, d square y by dx square. They are asking in terms of y alone. D square y by dx square sin y d square plus cos y into, shall I write here, dy by dx the whole square is equal to 0, because dy by dx into dy by dx, this dy by dx the whole square. And what is the dy by dx value? Anyone from this equation 2? Because you know dy by dx we got which from equation 2. From equation 2, what is dy by dx we can write? Shall we write like minus 1 by sin y? 1 by sin y is cosecant. Even here, instead of applying here UV rule, if you take sin y right side, that is again very easy. Okay, anyhow we have done here. So can I do the simplest form otherwise? It's better because here instead of doing this UV, you can do directly. Dy by dx. What is dy by dx here? Minus 1 by sin y. dy by dx. Okay, that is UV rule also better in NCERT actually. In NCERT means we need to write more number of steps. Cosecant y. Now you have to differentiate. When you differentiate here, d square y by dx square is equal to, I'm differentiating this equation too. What about this minus cosecant y derivative? Cosecant x derivative. Cosecant y into
Cot.
minus or plus? Minus cot y. Again, y is dy by dx. So left side is b square y by dx square is equal to minus into minus plus cosecant y into cot y into c here dy by dx value is what again? From equation 2 minus cosecant y. Am I right? So finally minus cosecant square y into cot y. That's it. This is the second order derivative in terms of y. So in second method, this is method 1. Second method, you can keep it as it is. You can differentiate directly. So dy by dx is equal to cos inverse x derivative is minus 1 by root over 1 minus x square. Then after again differentiate. That is, it will take more steps. Okay, because we can convert all x in terms of y. That is lengthy process. But if they give for 3 marks, here this question 2 marks or 3 marks, we can go through this method. If they give for 5 marks, we can go to some other method, like we can differentiate directly. Okay, any doubts, students? I differentiated by taking cos is left side, sin y dy by dx, then dy by dx value is minus over cosecant y. That is equation 2. Okay, that we can take as equation 2. Then differentiate directly, cosecant y is minus cosecant y cot y into dy by dx. Okay. So just only one question is there. Again, we'll do possible method 2 also. So don't be delayed.